Hey maths fans, we're looking at calculus, the topic of differentiation, and we're into normals. This comes very closely linked with finding tangents. So you need to know how to find tangents, or the gradient of a curve at a given point. Now normals link very closely with that. Let's see what normals are. Basically, a normal to a curve is a line perpendicular to the tangent at the point of contact. So let's have a look at that visually. We have a tangent touches the curve at just one point, the point of contact there, and a normal to that is just perpendicular to that. That word there is super important, perpendicular. Hopefully you have some idea of how we calculate perpendicular gradients, because that is a big part of normals. So our normal there, perpendicular, means it crosses at right angles with the tangent at the point of contact. So that's what a normal is. It is just right angles to the tangent. Now, if we think back to our work on perpendicular lines from straight line graphs, the gradient of the normal is going to be the negative reciprocal for the gradient of the tangent. Okay, that's what this means here. Negative reciprocal 1 over, and here we have the derivative at the point A. So that is the gradient at point A, or when x equals A, sorry. So yeah, let's put that into practice now, and let's have a look at how we could find the equation of a normal. So we're going to use our skills with differentiation, and we're going to apply them to this to find the gradient of the tangent first. Then we'll use that to find the gradient of the normal. And then we'll put that into a full equation. Okay, so let's start off by differentiating. dy over dx. For this one, the 2 comes in front of the x there, minus 4, and then the constant goes away. So there, hopefully that is pretty familiar. We've differentiated our function, or I should say f dash x, or dy over dx, whichever one you prefer. As we've started with fx, we'll go with that. So f dash x is 2x minus 4. Now, that'll tell us the gradient at any point. So we've got the point x equals 4, and therefore the derivative at the point 4 is 2 times 4 minus 4. 2 times 4 is 8, minus 4 is 4. That is the gradient of our tangent, and I'm going to call that mt. M for gradient, t for tangent, and whoops, that is our gradient of our tangent. Now to find the gradient of our normal, mn, we just do the negative reciprocal. Negative 1 over 4. Negative a quarter is the gradient of our normal. That is the fundamentals there of finding the gradient of the normal. What we now need to do is a little bit of work to try and find the full equation of that. So we know it's going to be in this form, y equals minus quarter x plus something. In order to find what c is, we need an x and a y value. So we need to find the point of contact. Now the point of contact is on this line, so let's find out what the y coordinate would be when x equals 4. So let's go for y equals 4 squared minus 4x plus 3. Whoops. Minus 4 times 4 plus 3. 4 squared is 16, minus 16 plus 3. I'm pretty sure that means that y equals 3. 16 minus 16 plus 3, yep. And now we have our y coordinate. So the point of contact is where x equals 4, y equals 3. We can now use that back into our original, back into our equation for the normal, and we're going to say, well, y is 3 when x minus a quarter times 4, x is 4, plus c. We'll use that to find what c is. Oops, a bit too far. And so we get 3 equals minus a quarter times 4 is minus 1, plus c, add the 1, so 4 equals c, and there's the equation of our line. Y equals negative a quarter x plus 4. Now, it's quite a lot of work to find the equation of the normal there. Good news, people, we can also use it using the GDC. We do need to understand all of this stuff. It is very important. They can ask questions that will ask a bit of your understanding, but if you've got the GDC, let's use it. So let's show how to do this on there. So we're looking at putting our function in, x squared minus 4x plus 3, and then we're going to draw that graph, and you see we just have a graph there. Now there's lots of things we can do with the GDC here, but really important is to go shift setup and go down to derivative and make sure that is on. If you turn that on, we can do all this stuff with differentiation. So turn that on with F1, derivative on. Now when I draw my graph and I find tangents and things, it'll tell me the gradient. So let's go to sketch, F4. This lets me sketch. You'll see tangent, norm. Those are the two things we're going to look at. Let's have a look at the tangent. There is the tangent. If we want to find it at x equals 4, press the number 4, and there we go. And you'll see it highlights dy over dx equals 4. The gradient of that tangent is 4. Very helpful. If I press execute again, it'll tell me the equation of that tangent, y equals 4x minus 13. It also does that for the norm. So if I click F4 sketch, go norm for normal, and you can see, press the number 4 there. There we see dy over dx equals 4. That's the gradient of the line. We want the equation of our normal. So I'll press execute again, and you'll see y equals negative 0.25x plus 4. And we had negative a quarter, which is the same thing. So there you go. That is using the GDC. Probably a bit quicker, more straightforward. If the question allows it, go for it. It's definitely useful to be competent with both techniques. All right, let's have a look at one more question. I recommend pausing the video now and have a go at this. Find the equation of the normal there. Pause the video, have a go at it. Assume you're paused now. All right, let's go through that, and I think I'll just show on the GDC for this one. And so we'll go back into our equation. We'll put in this time x squared minus 3x and then plus 2. And we'll draw that. There's the line. We want the equation of the normal. So I'll go to sketch, norm. The point is x equals 3. So we'll press the number 3. And there we have the normal. Press execute again, and it gives us the equation there. And negative 0.3333x, I think that's probably negative a third x plus 3. So the equation of the normal, y equals negative a third x. Was it plus 3? Yeah. So there you go. That's using the GDC. Normals, have a play with it, go and do some practice questions, get really proficient with this.